In this Indiamoon video we are going to cover classes in Python, which is one of those topics that can get really difficult for beginners, so let's approach this slowly. Most importantly, classes are a way to organize your code. They don't really allow you to do new things, instead, they are there to better organize what you already have. For an example, imagine you want to make some kind of game with multiple characters like mages, monsters, traders, and lots of other classes. It doesn't really matter for the example. Each character is going to have unique attributes and abilities. For example, the mage has health, mana, and weapons, those would be attributes, and cast magic would be a method, i.e., a function. For a monster, we might just have health along with an attack method. All of that information could be stored in a list or in a dictionary, but it would kind of be a nightmare to work with. The result might look something like this, where you have one extensive character dictionary that contains a mage with a dictionary, then a monster, and afterwards you would have lots of other characters. This would generally be possible, but this would not be fun to work with at all. Also, it would be kind of a pain to get functions in there. Using classes for all of that is going to be much easier. For example, via classes, we could create a mage object, and inside of this mage object, we could access mage dole and mage do mana. Also, if we wanted to call a method, we could simply call mage do attack and then we get some kind of output. We could even add arguments inside of this method. This would work like any other method in Python. We could actually add even more things in there, but let's get started with the basics of a class. For that, back inside of versus code, I want to create a new file which I'm going to call classes.py. And after that, let's start with a really basic example. I want to create a basic class. For that, you have to start with the class keyword, and then you have to give your class a name. The naming convention for that diverges a bit from what you have usually seen. For example, for a function, you would have something like a function name, which would be in a snake case, so we have all lowercase letters and spaces are separated by an underscore. For class names, you could do that, but the convention for those are Pascal cases. We always start with an uppercase letter, then we write the word like normal. Let's say I want to call this class test class. Also, notice here these are just conventions, both would work perfectly fine. After that, you need a double colon, and then we can write some code inside of this class, and notice we have to be on one level of indentation for it. The most simple thing you could be doing in here is, for example, create a test variable, which could simply be hello, and with that, we have a class. But this on its own is not going to do anything. For that, we have to create an instance of this class, which we do by simply calling it, and then the return value is going to be one instance of that class. Might sound a bit complicated, but basically what we usually do is we have to store the value inside of a variable. For now, let's simply call it test, and the value I want to assign it is the test class, and I want to call this. That would give us a class, but if I run the code, nothing is going to happen, which makes sense, we are not printing any information. But what we can do now is get access to the test class, and then get the test variable. Now if we run it, we get hello, the value we specified in there. This could be literally any value. For example, it could be a list with a couple of integers. If I run it again, we get the same list. You could, in fact, create multiple variables in there. Let's call it another underscore var, and then assign it something, and then this something you could also access via print. So test.another underscore var, if I run the code, we get both 1, 2, and 3. And something on top of that, we can totally update these values. Let's say before I'm printing another underscore var, I want to get test.another underscore var and assign it a new value. If I now run the code again, we get a new value. We have updated another underscore var inside of the test class. What is even better is we can create multiple instances of this class. For that, we will need another variable. Let's call it test underscore 2, and this one can get another instance of the test class. If I get that test underscore 2 and then print another underscore var, we are getting a new value for the another underscore var inside of the original test instance, but for test underscore 2, we have a whole new instance, meaning for this one, we are still getting the original value, i.e. something. This sort of system is going to become incredibly useful when you have something like a game where you want to have multiple instances of, for example, a monster class. It would make it quite easy to track multiple health values of all of the monsters for each monster individually. On top of that, what you can also do is create entire functions inside of a class. Let's call it a test underscore function, and for now, we are not going to go with any arguments. All I want to do is to print function in a class, and let's say I want to call this test underscore function on test underscore 2. This is going to work like any other method. I have test underscore 2, so the instance of the class, and then call the test underscore function without any arguments because we don't have any parameters. But now if I call this, we are getting an error that test class.test underscore func takes 0 positional arguments but 1 was given, which seems like a weird message because when we called the function, we didn't give it an argument. So what happened here, basically, when we are defining a function inside of the class, the first argument that will always be passed into this function is going to be the instance of the class itself, and by convention, this parameter is called self. If I run the code now, the code works just as intended. We have function in the class. The reason why you need this self, and by the way, you could call it whatever you want, Python doesn't really care about the name, self is just a convention, but the way this is used is as a way to access the class itself, or more specifically, the attributes inside of the class. Via self, we could get test underscore var or another underscore var. All you have to do is print self.test underscore var, for example. If I now run this, we get function in the class and 1, 2, 3. Effectively, this self is the internal equivalent to test underscore 2 from outside of the class. It's just a way for the class to refer to itself, and this you get access to via the parameter. If you change the name of this, it would be called something else. So just to recap, self refers to any instance of the class and must be the first parameter for all methods. With that system, you can target attributes everywhere inside of the class. Also, you could target other methods from inside of the class. It's incredibly useful. I suppose I should demonstrate this. Let's define another function, where once again we will need self, and on top of that, we can add any custom parameter. Let's call one with test underscore parameter, and then I simply want to print test underscore parameter. You can call this function either from outside of the class, so all the way at the bottom test underscore 2 and then another underscore function. For this one, we simply have to add the argument for the test underscore parameter. Self will always be added by default, you don't have to do anything. In this case, I want to print test, and then we are going to run this print statement. So I can run the code, and we are getting test indeed, that looks good. Also, what you can do when you are calling the test underscore function, you can simply get self and then another underscore function with whatever argument you want to call. In my case, I'm going to go with 1, 2, 3, and now we can see 1, 2, 3. And I hope you understand the utility of this kind of system. It is incredibly useful, especially to organize your code, because with this system, you can have logical entities where you have a mage class with mage health, mage mana, mage attack function, mage magic functions, and so on, and then create multiple instances of that. Besides that, then you can have monsters, heroes, traders, whatever you want, and all of this would be neatly organized, which is incredibly powerful. Before we continue, there are two major concepts that I do want to cover. We already covered self, that was the first crucial concept. Next up, we have some basic naming conventions. Variables in a class are called attributes, and functions in a class are called methods. That is literally the only difference between them, and if you are calling them variables or functions, it's a bit weird, but it's still totally fine as long as you know what you are talking about functionality-wise. Nothing is going to change. Finally, there's one more concept that we have to cover, and this is dunder methods. Those are special methods inside of a class. They always start with a double underscore and end with a double underscore. For example, one really common dunder method is called dunder init, which is run when you are creating an instance of the class. Dunder, by the way, stands for double underscore, that's all it means. The reason why these methods are useful is that they are being called automatically and you can pass arguments into them. For example, init can be used to create some custom attributes when you are creating a class, like the health for a mage or some kind of mana amount, something like that. Besides that, you could also specify something like lay, which is getting called when we are passing the instance of a class into the lay function. And I think that sounds a bit complicated, so let's play around with all of that. Also, I believe the basic class is a bit too basic, so let me comment out all of that. Instead, I want to create an actual example of a mage class in there. We once again will need the class name along with a name for the class. Let's call it mage. When we are calling it, we don't want to create attributes right away, i.e. variables. We want to instead call a dunder init method, which like any other method inside of a function will need self, and for now, let's simply print the mage class was created. After I have that, I want to create one instance of this mage class, which I'm going to store in a variable called mage. So, mage equals mage. And I think now from this example you can get an idea of the naming convention for a class name. You always want to use Pascal case, that way, it's quite easy to see when you are using a class, and then when you assign the instance of this class to a variable, you can use snake case. That's the main reason why this system is in place, so it's a bit easier to connect a class to a variable, but once again, not something you have to do. It's entirely a convention. Now, I can run the code, and we get the printout, the mage class was created, meaning this init method was called when we created one instance of the class. On top of that, what you could be doing is specify a couple of parameters. For example, for the mage class, I want to have a health amount and a mana amount, and those two parameters I want to store as attributes. To do that, I simply have to get self and then create a health attribute. The value of this health attribute is going to get the value of the health parameter. This kind of thing you do see fairly often, and it might be a bit confusing. Self.health is going to create a new attribute that is part of the mage class, while the health that we assign to it is what we are getting from the parameter. Those two are entirely disconnected, they just happen to have the same name, but that is not something Python cares about. Besides that, I also want to have self.mana, and once again, the value here is going to be mana. After that, the mage when we are creating the instance of the class needs to have a couple of values. Let's say 100 for health and 200 for mana. If I now run the code, we still get the same outcome, the mage class was created, but what we can do now is print self.health, for example, and then we get the mage class was created and 100 for health. Besides that, another dunder in method I just talked about is dunder lay. This one only needs one parameter, and then for this one, we have to specify a return value. For example, we could return self.health. What this allows us to do is we can print the length of the mage, and now if I run the code, we are getting 100, which is the same value that we have specified for the health. I suppose to get some different values, let me return self.mana, and then we get 200. And once again, using self here is incredibly important because that way you get access to the attributes of the class that are available inside of all of the methods. But other than that, dunder methods are just methods that are being called automatically or by some other function, like lay, for example. If you look online, you can find a whole range of dunder methods. There are actually quite a few, although most of them you are basically never going to touch unless you are working on something incredibly specific. You could even specify behavior. If you have a comparison operator or something like the end behavior inside of an if statement, but most of these are quite advanced and you basically never going to use them, the one that you are going to see all the time is thunder in it. This one is really common. At the very least, this is the one that you want to understand for sure. Now actually using those classes can be a bit overwhelming, especially in the beginning, but basically what you see in a lot of Python code is that you have one class, or rather one instance of a class, is influencing another instance of a class. In my case, I don't want to use the underlay function. Instead, I want to create something like an attack method where we need self, and then we need some kind of target. All that we are going to do inside of the method is target, and then get the health of this target, which we then want to reduce by a certain amount, let's say 10. After that, I want to have another class that is going to be a monster. Since this class is fairly simple, we can assign health right away. For example, we can set this to 40. That's basically all we need for this class, because afterwards I want to get rid of the print statement and then create one instance of the monster, which we do with monster equals monster. And don't forget to call the class. What we are now able to do is we can get the mage and then call the attack method. The thing that we want to attack is the target, which in our case will be the monster. And just to see what it's going on, let me print monster health before the attack and after the attack. So I'm going to copy it down, cut it out, and then run it after the attack. If we are now printing all of this, by default the health of the monster is 40. That happens on this line, and then we are attacking in, and afterwards we are printing monster health again, which has been reduced to 30. With that system you can make the various classes interact with each other. Once you have a bit more practice in Python, you are going to create much more complicated systems, but that's not something we have to worry about. I think this is a really good start. So with that, we can work on the final concept you have to understand with classes inheritance. This concept allows you to have one class that gets the methods and attributes of another class. Imagine once again you are making a game and you want to have a couple of characters that are reasonably similar, like a mage, a warrior, and let's say a traitor. All three of those are going to have some attributes that are going to be identical. They are all going to have some amount of health. They might all have some attack method, and they all might have, let's say, a death method. Because of that, it might make sense to create a base class with all of these methods, and then each of the classes you actually want to have in the game is going to inherit from that. That way you only have to write each function once instead of 3 times. And in terms of inheritance, a class can inherit from one class or multiple classes, and you can actually create entire family trees to illustrate all of this. Let's say we have a mage class, we have a warrior class, and we have a trader class. All three of those should inherit from some kind of parent class, meaning all of those get the same method, but this parent class could inherit from other things as well. For example, it could have one parent, it could have 2 parents, let's say it could have 3 parents. There's no limitation on the number here, and then each of the parents could have its own parents. Once again, especially once you have really complex code, this is what you see once in a while. Unfortunately, creating these kind of systems can get really complicated, and especially when you are getting started, this is going to be entirely confusing. As a consequence, I am going to focus on the really basic example where we only have a single parent. That's much easier to understand. I want to add another comment where we have inheritance. I suppose we can create another class. Let's call this one a warrior. For this one, we want to have a dunder init method with self, and we specified the amount of health, and that's all we need for this one. This health we want to turn into an attribute right away. Self health is going to be health. Besides that, let me actually copy the entire class. I want to create another one that I'm going to call barbarian. Now warriors and barbarians are going to be fairly similar. They are in fact going to have the exact same thunder in method. Also, they are both going to have an attack method that needs self and no need for a target for now. All I want to do is to print attack, which I want to do for the warrior and for the barbarian. After we have that, we can create a couple of instances. We want to have the warrior with a base health of 50, and then we can have the barbarian, which we are going to create with the barbarian class and the base health of 100. So far, all of this should still make sense. It's nothing that is too different compared to the mage class. In fact, all of this is much simpler. What we can do now is get the warrior and then call the attack method, and we can also get the barbarian and call the attack method. Again, in both cases, we are going to get attack. All of this is still working perfectly fine. However, the issue now is that we are writing the attack method twice even though it's doing the exact same thing. Which is okay for now, but once again, imagine each of these methods has 100 or 200 lines of code. Maintaining both at the same time is going to be kind of a nightmare and could also create a couple of errors where the warrior might end up behaving differently compared to the barbarian because you forgot to update its attack method. A better way to handle this system is to create another class that is the base class. Let's call it human, and this human is going to get the attack method. It still is going to need self, and in there, we simply want to print attack. Now I want the warrior and the barbarian to inherit from this human class, and this we do by adding parentheses after the class name and then specifying the parent class. In both cases, that is going to be human, and with that, we can get rid of the attack method for both of these classes. Run the code again, and we still get the attack method even though neither class has an attack method on its own. But they do have access to the parent class, and that way, we are getting the attack method back. If you wanted to have multiple parents, you could specify comma-separated values inside of the parentheses, although this is not something I want to do because that gets quite a bit more complex. There is, however, one concept that I do have to cover, and that is if you want to have a dunder init method inside of the parent class. Let's say for the warrior, we want to specify health and then something like the defense amount for the barbarian. Let's say I want to have some damage amount. And when running the dunder method of either of these classes, the only attribute that we want to create is for the unique parameter, i.e., defense for the warrior, which is going to get the defense parameter, and then damage for the barbarian, which is going to get the damage value. Health should be inside of the human class because this one is shared between these two classes. In there, we want to have the parameter health and then turn it into an attribute. Self.health is going to be health. Also, when we are creating the instances of these classes, we now have to specify a value for defense for the warrior. Let's say 5.5 and damage for the barbarian is going to be 8.1, completely random values. If I now run the code, we are still getting attack. However, let's see what happens when I print warrior.health. We are getting an error that attribute object has no attribute health. What happened here is that we are passing health into the warrior and the barbarian, and we are capturing all of that via the health parameter. But then we are never passing it into the parent class, meaning this health or rather this standard init method is never being called. As a consequence, neither the warrior nor the barbarian have any amount of health. The way around that is with a special function called super. This one calls the parent class, and then you can call the dunder init method on this parent class, which in our case wants to have the amount of health. And this we have to do both for the warrior and for the barbarian. That way, I can run all of this again, and now our warrior has an amount of health, whatever we specified. So if you want to call the dunder init method of the parent class, you always have to start with super and don't forget to call it and then the dunder init method with whatever arguments you want to pass into the dunder init method. So that would be the basics of inheritance. It can get much more complicated, but this is what you see fairly often, and I think if you practice a bit, it's not too hard to understand. As a matter of fact, let's do an exercise. I want you guys to create a monster class where you can set a health and a damage attribute on creation. On top of that, this monster class should inherit from some kind of entity class to get the attack method. The attack method should print attack and the damage amount, the one that you have said earlier. Finally, I want you guys to do some research so that when you are passing an instance of the class into the print function, it should return a monster with X amount of HP. Help should be generated dynamically in there. That should be quite a bit of work. Pause the video now and see how far you get. Back in the code, I want to comment out all the stuff we have done for inheritance and then add one more comment for the exercise. I want to start by creating a class called monster. For this one, since we want to set a couple of variables on creation, we need a dunder init method with self. Then we need health and we. Also, we want to set the amount of damage. Both of these need to be turned into attributes, meaning self.health is health, and self.damage is going to be damage. That's a pretty good start. Now we can create an instance of the class and specify for health, let's say 100, and for damage, 10. To see if this is working, let's print monster.health. I can now run all of this, and we are getting 100. That's a good start. Next up, then we want to specify a parent class, which we are going to call entity, and the monster should inherit from this entity. All the entity class has to do is to have some kind of attack method where we have self and no other parameters. All we want to do in there is to print an F string that says attack with, and then we get self.damage and I guess damage right after. And I think I should explain it might be weird that we have self.damage inside of the parent class. What is really important to understand is that we are calling this defined attack inside of the monster class, meaning the self in this case is going to refer to this class or rather the instance of this class that we have created. Because of that, self.damage is going to refer to this self.damage, which is exactly what we want. Well, this is actually all we need. What we can do now is call monster.attack. If I run the code, we are getting attack with 10 damage, which is exactly what we wanted. Finally, I want to have the ability to simply print an instance of the monster. If I now run the code, all we get is a monster object at some point in our memory. This isn't particularly useful. I would rather have some kind of string that tells me something about the monster, and for that, we will need another dunder init method. This one is called __str__ or __rep__. It only needs self, and the only thing that we have to do in there is to return some kind of value. In my case, this should be, once again, an F string that says a monster with, then we want self.health and HP. If I now run all of this again, we are getting a monster with 100 HP because of this print statement, which is actually super handy, makes it quite easy to understand what's going on and to illustrate what you want to do with a particular class. But anyway, with that, we have a pretty good understanding of classes, or at least I hope you do.